Hey guys, welcome to Master Programming MFC programming series. In this video, let's talk about message maps in MFC. Why we need message maps, how to write message maps, and what is the purpose of message maps in MFC. So let's get started. As we all know, Windows is an event-driven or message-driven operating system. When an event will be generated is whenever an user performs some action in Windows, event will be generated. An action can be like mouse action or it can be like keyboard action. So whenever a user presses a keyboard key, Windows will generate a keyboard event. Whenever a user presses a mouse key, Windows will generate a mouse key press event. Or whenever a user moves the mouse, Windows will generate a mouse move event. Whenever Windows generate events where these are sent. So when an event is generated, Windows will send an event to the appropriate application message queue. So in Windows, every application should have its own message queue to handle all these messages or events with its window procedure. To understand how a message queue is like and how the window procedure is like, I will start with a small Win32 application. Then we can go for MFC application. So this is my Win32 application I have written already, and the execution of Win32 application starts with WinMain function. So here is my WinMain function. Inside WinMain, I have one message loop. So this is the message loop for this Win32 application. So message loop is infinite so that it keeps on processing the messages whatever it comes to this Win32 application. So get message function is used to fetch the messages or event from the message queue. Once get message fetch the message from message queue, that will be sent to the appropriate window procedure for that Windows application. How does how does it send to the appropriate window procedure is by using dispatch message function. So I will repeat again. Get message will fetch the event or message whichever it comes from the message queue. Once the message is fetched, it will send it to the appropriate window procedure. How it will send to the window procedure is through this dispatch message function. And there is one more function called translate message. So translate message is nothing but it is used uh, in keyboard. Every keys is identified with virtual keys. So translate messages used to translate these virtual key codes equivalent to ASCII key values. So I will repeat one more time. Translate messages used to translate virtual key codes into its equivalent ASCII values. So in a keyboard key, not all keys will be having its equivalent ASCII values. Some keys don't have ASCII values. That keys we call it as system keys. Say like control key, shift key, alt key, and function keys don't have ASCII values. Those are called as system keys. So how do we process a keyboard key which does not have ASCII value is we'll be processing those keys by virtual key codes and it will generate a different keyboard event for those keys. So we can see all those things in later video series. So now we have seen this is the message loop for this Win32 application. What we have seen here is whenever a message comes to my Win32 application, Get message will fetch the message from the message queue and it will send to the appropriate window procedure. How it will send to the window procedure? By this dispatch message function. Now, where is the window procedure for this Win32 application? So, if I scroll down, so I can see a function here. So, WinProc. So, this function name can be anything, but here I have written as WinProc. So, which will take four parameters. The first one is handle to the window, message, L param, and W param. So, message is what message my window process, my WinProc is going to process. Window is like from which window, window handle, for which window it is going to process the message, and W param and the L params are for mouse related movements and for menu related events. So we can see all those things in the later video series. So this is my window procedure. So once dispatch message sends the message to the window procedure, inside this I'll be handling all the window messages. It can be either mouse message or keyboard messages. So so here the window procedure will be having one switch statement, and here message is like to identify what type of message it is. It is a mouse message or keyboard message or some other messages. So inside this window procedure, I'm having one message called wm underscore command. So when this wm underscore command is generated, is like whenever I click on a menu item in a window, say like file menu or edit menu, right? Whenever I click on menu items, wm underscore command message will be generated. Then for that I need to have some handler, right? So for that it is written inside this one. So here under wm underscore command, here wm id, okay. So these are all id for menu item. So say like if I click edit, go to, here this go to will have some id. I assume like idm underscore about is the id for this about Microsoft Visual Studio. When I click on this, what will happen? It will display one dialog box. So that logic will be written inside this function. So it is showing one dialog box, and when I press OK, I am closing that dialog box. So I have IDM exit. This is one ID for one menu item. Whenever I click exit, so in file menu I have exit. Assume this is the ID for exit. Once I click exit, what it will happen? It will close the window. So there is a logic written here. And don't have if my message don't have any handlers, then what should I do? Then it should be sent for default processing. How I can send for default processing is with this function def window proc. So def window proc is used to do default processing. So this is one type of message we handled in my Win32 application, and we have handled wm underscore paint message. So what should we do whenever wm underscore paint message comes and wm underscore destroy? So I will build this Win32 application. My build is succeeded, and I will run this Win32 application. So my Win32 application looks like this. So I have file, exit, and I have help about. So if I click on about, it will display one small dialog box. Press OK, it will close the dialog box. And if I click on exit, it will destroy that window. So we have seen how messages are handled in Win32 application and how messages are dispatched to its window procedure, and how business logic is written inside window procedure for that Win32 application. So just to repeat again, so WinProc is the window procedure for my Win32 application. So, and this is my message loop for my Win32 application. See, generally my application can have message loop or it don't have message loop. If my application is not having a message loop, then we are not going to handle any messages in my application, right? I am not having my own logic. So it will be sent for default processing. But every application should have one minimum one message loop. So let's go to MFC. How messages are handled in MFC? What is message maps or message map macros in MFC? So this message loop in MFC is present in a function called run function. Okay. This equivalent message loop in MFC is present inside a function called run function. So where does that run function is defined is it is defined in WinApp C WinApp class. So I'm right clicking C WinApp class. I'm going to definition, and if you find run, so my run function is present here. Inside this run function, message loop is present in MFC, and this run function is virtual, so I can override this run function inside C WinApp derived class if required. Okay. So run function is responsible for message loops in MFC, or it will process the messages whatever my MFC application gets. So once a message comes to an MFC application, what it will do, as a loop is very similar to Win32 message loop. So there will be a get message for an MFC application which will fetch the message from the message queue. Once it fetches the message from the message queue, where it will send us, it will be sending to a function called AFX WinProc, who will send messages to AFX WinProc. Again, dispatch message will send message to this AFX WinProc. So AFX WinProc is nothing but it is a Windows procedure. So where this dispatch message present is, as we have seen in Win32 application, so it is present inside this message loop for dispatching the message to the appropriate Windows procedure. Okay. Once AFX WinProc gets the message from this dispatch message, what it will do? It should find its appropriate C++ object. How it will find its appropriate C++ object is AFX WinProc internally calls from handle permanent to find the appropriate C++ object where this message handler is written. So every Windows in MFC is a class, right? So here we are having a class called cFrameWind, which is used to represent a window object. And to create a window, we have derived this cFrameWind from by myFrameWind. So to get the C++ object, AFX WinProc will call internally from handle permanent, and every window will be having window handle, right? From that handle, it will be getting that uh, C++ object. So once that C++ object is retrieved, then it will find its appropriate winproc function. So there is present winproc function for that window object. What that winproc function will do is it will find the message map entries. So in MFC, the messages are handled by these macros: declare message map, begin message map, and end message map. Okay. So how my messages are stored in MFC is a question now, right? So if you expand, whenever, if you right click and go to definition for this declare message map, declare message map is expanded as below. Okay. So whenever declare message map is expanded, there will be an array called message entries, and this array is of type afx underscore message map entry, and this array is static array. So static array for my class. So there is my frame window. So what is the purpose of static array? Though I create any number of objects, only one array will be available for all objects. It won't create one array for one object. So though there are many objects, only one array will be present. So it is kind of one too many. So there will be declare underscore message underscore map is expanded like this when that macro is processed. So there will be one static array called message entries, and this message entries is of type afx underscore message map entries. All the messages in MFC, whether it is a keyboard message or whether it is a mouse message, whatever may be the messages Windows generates and sent to my application, all the messages will be maintained in this static array, and the elements of the static array is of type afx underscore message map underscore entry. So if you right click and if you go to definition, so this afx underscore message map entry contains two elements out of these element which is important. One is id. Id is nothing but message id. So whenever a message is generated or whenever an event is generated, everything should have an id. So that id is stored in this field, message id or event id, and appropriate handler for that message id or event id is stored in this field. Okay. And there is one more structure called afx underscore message map. What this structure will do, AFX underscore message map will store AFX underscore message map will store a reference to message entries array, and it will store a reference to base class message map structure. So, for example, so here I have a C framewind derived class my framewind. So what AFX message map will store? So we know that declare message map is expanded to message entries array. So we have seen here, right? So what AFX message map will do is it will store a reference to local class message entries array and base class. Local class here is my framewind and base class message map structure. So which will again contain its local reference to its local class message entries array and base class message map structure. So it will travel up to the hierarchy like this. Okay. And there is one more function called get message map. So this will return the address of AFX underscore message map structure. Why we need to have the address of AFX underscore message map structure? Because this is the message map which is storing a reference to local message entries array and base class message map structure. So if you see here, AFX underscore message map contains two elements. One is a reference to AFX underscore message map underscore entries, which is message entries array, and it is a reference to message map structure itself, which is, if we see, get base map, which is a reference to the base class message map structure. Why is such references kept as? If I am not handling any messages in this present class, then what it will do? It will search those messages upward in the hierarchy. So if I'm not handling any messages in this class, then it will search those messages in the C framewind class, whether that message is handled or not. If in C framewind that message is not handled, again it will go one level up to the hierarchy. So the base class for C framewind is C wind. So if that message is not handled in that C wind, then it will go one level top to the hierarchy, and the base class for C wind will be CCMD target. So in MFC, every class should be derived from CCMD target to handle this messages. So C framewind is indirectly derived from CCMD target class. If any class is derived from CCMD target, then those classes in MFC can have its own message maps. So how this we have seen there's a message entry, static message entries array, right? Once again. So how this message entries array is filled is whatever entry we write between begin message map and end message map is filled in this array message entries, which is of type AFX underscore message map entry and static, and the element of these message entries is AFX underscore message map underscore entry. So as we have seen, It contains two elements which is of important, ID and function. That is the message ID and handler to that function. So here, and we know like messages can be of any type. It can be like a keyboard message or mouse message. So these are some examples of the messages: wm underscore command and appropriate message map macros for MFC, wm underscore l. These are few examples I have mentioned here for wm underscore l button down, and the appropriate handler will be like on underscore wm underscore l button down. So inside this, I have written on underscore wm underscore mouse move, and the appropriate handler will be like on mouse move. So this entry will be placed inside this message entries array, static array. So if I have written some logic here, whenever I move the mouse, then that appropriate business logic will be executed for this application whenever I move the mouse here. Since I have not written anything, so nothing will happen. If I don't have any message maps here or message entries here, it will be traversed up in the hierarchy. If it does not find any entries, then it will be sent for default message processing. So this is about message maps in MFC. So if you have any doubts, please write down your questions in the comment section. Meanwhile, if you like this video, please like and subscribe to my channel. Thank you.